Hey guys, in this lab we're going to show you how to parse GPS data using both Matlab and Python in order to visualize your GPS data on Google Maps and Google Earth. So to start, I'll show you a sample of what your GPS data might look like. This is a text file with a lot of GPS data that was taken over the course of a couple hours on a high altitude balloon flight. So we'll be able to show both a 2D representation of this data and a 3D representation of this data using Google Maps and Google Earth respectively. So to start out, using MATLAB, we're going to read in our data in the text file called gps.txt, and we're going to scan that document using text scan with the file ID that we designated up here, and we're going to be searching for strings in that text file. And we're going to initialize a cell array that's large enough that we're confident that we have enough space. And this for loop is going to read in that data one row at a time and load it into a variable called GPS cell, which will be a cell array. So if I run this section of code, you will see that GPS is a cell that is 7,878 rows long. If I open that, you'll see that each component is one line of GPGGA data. So that's where we're going to start out. Alright guys, so we'll move on to the next section. In this section we're going to start splitting apart those GPGGA strings. We saw in the previous section they were just one long string each, but we need to separate those values that are separated by commas. So that's what this section of code is going to do. So we'll go through it loop by loop. This first loop goes through the entire cell array that we generated in the first section. And as you can see, GPS cell is still over here in our workspace. And each component of GPS cell is now a string vector with the components now separated. Before we had commas in between each component here, and now we can highlight certain components individually. So we have our timestamp, we have our latitude and longitude right here with directions, and I believe column number 10 here is going to be our altitude measured in meters. So as I said before, that those latitude, longitude, and altitude are the components that we're mainly focused on. Alright, so now in this next loop is going to do something similar, but it's going to break down our cell array even more so it's easier to work with. Alright, so you can see that section of code is done running now. You can see that it generated a new variable called endResultGPS. And I initialized this variable up here as being empty. You can see by those open brackets, those hard brackets. We can see that endResultGPS is now a string array with each component of that GPGGA string separated. So this is going to be now very easy to work with, because we can reference certain cells independently without having to reference an entire line of GPGGA data. So in order to do that, all we did was we parsed through the GPS cell, the cell array that we generated in the above section, and we said if its length is 15, then we're going to put that section of GPS cell, we're basically going to condense it further. And then we're going to take that condensed version and stick it into a new row of endResultGPS. So we're not throwing away GPS cell, we still have it over here, but we're just copying it into a new variable. If you really wanted to, you could rewrite GPS cell over itself, but in order to make the debugging process easier, we just made a new variable, called it endResultGPS, and kept it. That way we can look back at GPS cell if we wanted to and see what condition it's in now. Alright, so now that we have end result GPS in a format that's really easy to work with, we're going to start splitting its components apart. Let's open that back up again so we can see what it looks like. All right, so this first column is just our GPGGA. Oh, that's all it says. It doesn't offer any unique data, so we really don't need that at all. The second column is our time. It's a timestamp. So you can see this line of code just basically separates, it's all rows but the second column of end result GPS, and it converts it from a string to a double, and it assigns it to a variable called time GPS. And that's just gonna be a vector of our timestamps. And the format for doing that is gonna be pretty consistent for the rest of this section. All we're doing is identifying that we want to take all rows from end result GPS. We're gonna take out a certain column and then we'll convert it to a double. So that's what we're doing with latitude as well. Now, the format that GPGGA gives you is kind of unique. Let's open back up end result GPS. This third column is going to be our latitude. Now, this number right here, 4127.1867, that's a format that the GPGGA lines give to you. And you can see that this format is kind of strange. In this example, 4124.8963 actually means 41 degrees and then 24.8963 minutes. And those two values are just concatenated on to the end of each other. So what we need to do is we need to separate, in this case, that 41 and then the 27.1867 and convert that into a number that we can actually use. Because Google Maps and Google Earth use a number that's purely degrees. So we need something like 41 point something 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 degrees. So that's what this next section of code is going to do. Let's run the time here. You can see we now have a time vector. I'll run this first latitude so you can see what I did. Latitude 1. It basically just grabbed that column from end result GPS and divided it by 100 and then converted it to a double. So now we have 41.27. That's not what we want, but we're getting close. Latitude 2. Basically just took latitude 1 and gave it the floor command so that now we just have 41. It just rounds down to the lowest integer below that double. So you can see that here that I was kind of repetitive. You could have condensed this code a lot more. I just did this so you can see how it works. So now that we have all those integers, the 41s, we need to add on the decimal degrees. So remember, latitude 1 was the 41.27, latitude 2 was the 41. So if we subtract those two, we should get how many minutes we have. And if we multiply that by 100 and divide it by 60, we'll now have a new variable called degrees 1, which should be in the format that we can now input to Google Earth and Google Maps. So we have 41.4531 degrees. I repeat, this unit is in degrees. And that's what we want. So this whole section of code basically just dealt with latitude. This section will do the exact same thing, but instead deals with longitude. And then line 44 here, altitude, all we did was extract that from end result GPS. It was the 10th column. We didn't have to do any math with it. We just extracted it. I believe that's in units of meters. Last but not least, we created a variable called Earth Map Data, and that creates a new matrix with only the information that we want. We'll have longitude here, latitude here, and altitude. So let's run this section. And now open Earth map data. And you'll see that we have a matrix with only the values that we're interested in, latitude, longitude, and altitude. And now this is very easy to work with in putting it into Google Earth and Google Maps. So we'll do that in the next section.